So today we have same as yesterday problem. Given two numbers a and b, we want to find in this range how many numbers have waves in the base 10 representation, like 1, 2, 1, 2. We have this volley, hills and volleys, and this is just plus 2, and imagine we have all of these numbers like from 0 up to 2000, and we have, this is just one case of one number. We have to find entire sum of all the range. Yesterday problem was just 10 to the power of 5, and we could just iterate and check every number. But today is hard problem, 10 to the power of 15, and we can't just iterate all the numbers to check them. However, we still given this a and b, and take some big numbers like 1, 2, 3, 4, 5 and up to 15. This is a long number. Now, to check this, we use two tricks. First trick is you define the range problem. Each range problem can be defined as subrange or range difference. So this is would be solution of f b minus f a minus 1. This is a standard trick on the lead code that you can use and have to remember. Just if you have the range from a to b, you will always can, almost always you can do this trick. The second trick is digit dp. If you have imagine you have a range from 0 up to some number, let's call it a b c d, where each a b c is just some digit. Then if you have to compute something for this range that starts from 0, you can use digit dp, and this digit dp is that you just iterate over each digit on this maximum of this range, and you assuming that each digit can be arranged from 0 to 9, and from each of the current, the next would be also ranged from 0 to 9. But as it's not as simple, because you have this maximum and you shouldn't be overflowing its value. So it's not that you can always do from 0 to 9. There is some case where you have to limit by current digit of the maximum. So this is not simple dp, it's digit dp, and the state is I, current position. The next is, let's skip that that we have problem of valleys and hills for now. We have to know that we allowed or not to overcome the limit. So can we use all the range or not? And we can put it as a boolean value all. This is just some variable. Okay, and now let's look about our state. So we have to find hill or valley, so we should check the previous and previous, and the current would be the right border. and then we have three variables. So we have previous, and we have previous, and the I position is the current variable. So this would be the state. It wasn't simple for me, and I didn't solve it even, so I looked at the solution yesterday and I didn't pay much attention to it. Now today was my day where I would pay, or had paid attention. So now let's look at the code. It would be simpler for me to explain because this is hard. So my attempt was almost 1 hour of trying to make it work, and this was the code that I arrived at 1 hour mark. So this has some mistakes. For example, like this, the count. So to count heels and volleys, you have to check your current variable digit is bigger or less than current is bigger than previous, current like this, bigger than previous, and previous bigger than previous, like this, or current less than previous, and previous less than previous. This is a heel and volley. This is a yesterday problem. Now this is how I checked it, but my intuition was wrong about first. You can't just do counter ++ because you have a tail of, so imagine you have 9, 5, 9. This is a current, this is previous, and you have a big tail of zeros, for example. So it's not just you do +1, because you can do like 9, 9, 9, 9 of those numbers. Like this could be, or maybe not, I'm not sure, but this tail is matters, so you have to consider it. Now this is one mistake. The second mistake was how to start these counters, and I use I position from this second or third position, and this is not correct because it's just not correct, because you have to, if you considering this 1 2 1 2 number big, okay, and you're trying to count, you have to consider this number that starts with 0, and it can be any other numbers like that, or you can do, okay, let's look at the code. I can't explain it. This was accepted, and it was accepted with help of Gemini. You can see this code is much bigger than what was wrong. That was my solution. So the first is the tail of, if you have this heel or volley, your tail is depend of, can you take all the values on the next or not. If you can take all the values, you can just do take entire 1000, or how many of them, it's a power of 10. If not, you have to consider just what your initial maximum is, take last digits from it and do +1, because 0 also counts. And what about start? You don't, instead of using I as a trigger to start to count, you have to use something else. I use this pp and p marker values like -1, just to be sure I took them, because there was some interesting cases where you have 0 0 and then 1 to 1, and that would mean I is already 2, but you can't take this one because you didn't take the previous digits. Your all prefixes 0. That's why I use marker values instead of I more equal than 2. So this is it. Basically, the z variable is about have I leading zeros or not. No, basically this case. And a leading zero is only when you have 0 flag defined as 1 from the first call, and you just start. Your d is 0, so it always propagates like this only for the first cycle of the loop, and it goes here like this, and then you use it to define this p and d. Should you use them, or should you place marker as you placed it in the initial call? This is the trick to solve this particular corner case. It was very hard for me to just understand and then make it work. Okay, this is the idea was on the surface you just use dp, you use digits, but as I told, this how you count this values is not trivial. You have to consider suffix, and how you do the leading zeros is also not trivial. You have to use marker variables and leading zero flag. Okay, let's look at the golfit version of the same code. So this is a Kotlin one. Basically the same. I just made it a little bit shorter, and I use this instead of all and 0 flags. I use T as tight. Tight mean you have to abide this your maximum value x. So if your new tight is if you were already tight, basically if it's all but inverted, and it's boolean instead of integer. So this code is pretty like ciphered. Now let's look at the Rust. It's the same. I didn't proud of this code, and I didn't proud of my skill for this, but at least I survived this problem today. Okay, that's it for today.